Greetings and salutations, magical chemists. Are you ready to have fun with pH and POH? You might be thinking it sounds crazy to take away your calculator and expect you to do logarithms in your head. But actually, logarithms are relatively straightforward to do without a calculator, as long as you engage in some creative rounding. This is because a logarithm is an inverse function of an exponential. So by definition, if you take the log of 1 times 10 to the something power, you're basically undoing the 1 times 10, you just get x. So if you want to find the pH, of course, that's the negative log of 1 times 10 to the negative x. Notice that negative and that negative cancel each other out. So you just get x. So let's look at an example, because it's actually pretty straightforward. So I'm going to skip down to number 3, since that's the one giving us the concentration of protons. Now, this, of course, is not written in scientific notation. You're going to want to put it in scientific notation, because that's what makes this easiest to do. And 0.01 is just 1 times 10 to the negative 2. And that makes the pH really easy to find, because if you take negative log of 1 times 10 to the negative 2, the pH is 2. Of course, we can't forget about the glory of sig figs. Because this number that was given had 2 sig figs, my pH has to have 2 sig figs, but those sig figs show up after the decimal. So 2.00 would be our final answer. But notice, it was the sig fig part that was annoying. It wasn't the mental math. Now, of course, if the pH is 2, you just subtract from 14 to get the POH. So POH would be 12. For sig figs, because we're subtracting, keep the same number of sig figs after the decimal. So we have 12.00. And that means it's really easy to write the concentration of hydroxide, because it's just going to be 1 times 10 to the negative 12. Well, 1.0 times 10 to the negative 12, because of course, those pesky sig figs. But hopefully you can see that these conversions back and forth are relatively straightforward. Let's do one more together, and then you can try the rest on your own, and it'll be delightful. Let's go ahead and do number 1. So this time they gave you the POH of 4.0. Well, that means that our concentration of hydroxide is just 1 times 10 to the negative 4. You might be thinking, but wait, is it really just 1? What about sig figs? Haha, that is with the right number of sig figs, because there's only 1 sig fig after the decimal, so we only get to keep 1 sig fig. It really is just 1 times 10 to the negative 4th. Of course, once you know POH, it's easy to find pH by subtracting from 14, and 14 minus 4 is 10. So, since the pH is 10.0, the concentration of your hydronium, or your proton concentration, must be 1 times 10 to the negative 10th. Okay, go ahead and try the 3 that we have not done, and then when you are ready to check your answers, unpause the video. And there you have it. Hopefully that pattern is starting to make sense. So you might be thinking, yeah, that's fine, that's great, but all those numbers started with a 1, 1 times 10 to the something. What do I do if it doesn't start with a 1 times 10 to the something? You're gonna round it to 1 times 10 to the something. Remember, we're looking for easy numbers when we're doing math without a calculator. So the goal is to round either up to 10 or down to 1, whichever one is closest to your coefficient. So if you had a number like 3.95 times 10 to the negative 2, you're just going to say that's about equal to 1 times 10 to the negative 2. But 5.2, that would round up. So now we have 5.2 times 10 to the negative 8 becomes 10 times 10 to the negative 8. You might be thinking, but wait, now there's a 10. Isn't that going to screw with stuff? Kind of. The thing is, you can't leave this as a 10. You have to drop it down to 1, which means changing your exponent. Remember, if your coefficient goes down, the exponent has to get bigger. So 10 times 10 to the negative 8th is just 1 times 10 to the negative 7th. So the goal is, no matter what, you end up with just 1 times 10 to the something, because then all the logarithms are easy. Take a moment to round these 2 last ones on your own, and when you're ready to check, unpause the video. Okay, that first one had to round up to 10, So you had 10 times 10 to the negative 11th, which is 1 times 10 to the negative 10th. And the other one rounded down, so that one was more straightforward, 1 times 10 to the negative 9th. All right, so let's go ahead and do some practice. And you want to know the good news? We're going to ignore sig figs, because most of the time, if you're doing math without a calculator, it's multiple choice, and the sig figs won't be a problem. Let's try one of these together, and then you can go ahead and work on the rest of the practice problems on your own. We are going to go ahead and do let's do 1 and 2, and then you can have 3, 4, and 5 all to yourself. So for number 1, we have a POH of 4.67. We are going to round that. Now for pH and POH, those we have to round to the nearest whole number. Those don't have to be 1 or 10. Because remember, pH and POH refer to the exponent. So we just need whole numbers. So 4.67, that's pretty much 5. And if the POH is 5, the concentration of hydroxide is just 1 times 10 to the negative 5th. Of course, if the POH is 5, 14 minus 5 gives us 9 for the pH, which means the concentration of hydronium is just 1 times 10 to the negative 9th. Okay, let's try the second example. Now this one's a little trickier because 0.6, well first we want to write it in scientific notation. 0.6 is just 6 times 10 to the negative 1. Well, we're going to round that to a 1 or a 10, and 6 is closer to 10, so this is just 10 times 10 to the negative 1. But we need to rewrite that with a 1 in front, so that's actually just 1 times 10 to the 0, which of course is just 1. You want to leave it written as the 1 times 10 to the 0, though, because we still need that number. Because if our exponent is 0, our POH is 0. So this is extraordinarily basic, and would, of course, make our pH equal to 14. And the concentration of our protons, 1 times 10 to the negative 14th. All right, the rest of these are yours to practice, and the answer key will be posted on my website. So thank you for playing with the glories of chemistry.